Hello virtual people, I am Mickael Sereno, third year PhD student working at INRIA in France, and today I shall present a recent TVCG paper which surveys the vast majority of work interested in the use of augmented reality for collaborative work. So, why have we performed this new project? The number of papers investigating the use of augmented reality for collaborative work is pretty low. However, we think that this research area deserves more consideration. So we wanted to give a survey for newcomers and practitioners about what systems did researchers provide to their users for which scenarios. While there were numerous surveys published before, they mostly focus on scenarios without giving much information about the systems. However, since we come from the HCI and the VIS communities, we think that systems might diverge a lot based on the scenarios, and also because they did not consider the technological breakthrough of 2016, where Microsoft released its HoloLens. To describe those systems and scenarios, we propose a new taxonomy. This taxonomy is first based on the space and time matrix that the CSCW community usually rely on, which tells when and where do users meet. Then, inspired by Ansett all symmetry dimension in their survey, we propose to describe the systems based on whether or not users use the same set of hardware and whether or not those users share the same role in the collaboration. Finally, we describe each system based on their input and output devices and interfaces. We use this taxonomy to classify a total of 65 papers that should describe an AR system. We first systematically looked at the main AR and CSCW conferences, respectively at IEEE ISMA and STM-CSCW for papers published after 2008. This yielded a total of 18 papers. Since this number is pretty low, we completed with an opportunistic approach in order to add key contributions from other venues, with a focus for papers published after 2008, and also to exemplify multiple aspects that the systematic approach couldn't totally grasp. 2008 is basically the date where smartphones were available in the consumer market, which is a huge technology breakthrough that invited more research in the field. So, let's see some distribution metrics. Most of the papers discussed about synchronous use cases. The asynchronous ones are currently resumed to a set of users consuming annotations created by others. Then, we see that there was a shift in time where researchers started to extensively study remote scenarios compared to collocated ones. We hypothesized that remote settings pose stronger challenges than collocated ones in just understanding of what colleagues are doing, as there are no passive awareness information concerning these remote users. As remote users might not have the same needs, we clearly see in the survey that most of the systems proposing remote collaboration rely on asymmetrical technologies, with users using dedicated technology to suit their specific needs. This number might also be explained by expert guidance being the most studied remote scenario. Finally, even if we now know AR headsets mostly through the HoloLens that is only 5 years old, most of the systems rely first on headsets, followed then by handheld display. The survey being pretty long, I would like in this presentation to focus on output and input devices. SCR considers the place of 2D screens in AR settings. In our survey, researchers used 2D screens for an expert to remotely guide a partner, where this expert needed mouse and keyboard interactions. Those 2D screens were also used by multiple experts to follow collaboratively with a remote AR user. Those screens also allow non-AR users to follow what is going on in the AR local space. As those users cannot see directly the world in 3D for multiple reasons, for example because there are too many users or because they are mostly passive, 2D screens allow those users to understand what is going on. Third, they can serve as support for common data information. And finally, these 2D screens are usually linked to usual tools and software that users may need in most aspects of their work, for example spreadsheet manipulation. Let's now consider research questions we find interesting to investigate. While most papers focus on headsets, and tracking interfaces are tiring and sometimes imprecise. Because some settings require multiple functionalities, like immersive analytics, multiple researchers investigated the use of hybrid interfaces to give the best of each device for users. Still, we did not see research that investigate which devices are better for what, and when does one switch from one device to another. Moreover, AR devices usually propose to deal with 3D contents, to interact with them in the 3D space. As middle gestures are tiring, some of the interactions can fall back to the additional device. For 3D manipulations, for example, how do we translate the 2D views and interaction to the 3D space? Finally, those additional devices are usually only seen by their owners. As they then act as private displays, what kind of awareness cues, which are important in collaborative work, should be conveyed and how to convey them. as we come from the visualization community, we also wanted to discuss a bit more about the specific case of collaborative immersive analytics. This research area mostly concerns currently VR settings, which can be explained based on the three principal AR displays by tablets and smartphones having no clear benefits compared to workstations because they have too small screens, they are smaller screens and are way less powerful. Spatial augmented reality are already similar to caves where users can already see each other's, caves that are already used by the VR community extensively, and because before 2016, with the release of the HoloLens, headsets had not enough computing power for such scenarios while having higher requirements compared to 2D screens, such as having a minimal refresh rate. But why should one consider AR over VR? Let's consider headsets. Such devices propose to merge the collaborative and the working spaces in the user's physical 3D space, where users can both interact with their collaborators and the visualizations without changing their focus. This leads to multiple research questions, including which AR devices to use for analytics scenarios. For such scenarios, scientists mostly rely on orthographic views for precision. Immersive devices, such as headsets, can however provide such precision using perspective views matching the human anatomy. But those devices have lower computing power and are usually limited to gestures, voice, and eye-gaze interface. For that, we think that an hybrid approach could be the solution. Should we use workstations in addition to AR headsets? While having well-known user interfaces, the merge between the collaborative and the visualization spaces is broken. Users are also bound to one spot, whereas AR headsets usually invite their users to move around. Should we rely on multi-touch tablets? While being mobile devices and proposing well-known user interfaces, they lack the usual keyboard and mouse interfaces and have lower computing power compared to workstations. At the end, in which scenarios can AR be useful for collaborative immersive analytics remain to explore. And there are much more discussions and insights in the survey that I invite you to read. Thank you for listening.